Good day, everyone. We are the proponents for the proposed airport in Tanauan City, Batangas. I am Son of Faith P. Buku, together with my team, Charles Dave Gutierrez, Bon Jerome Moren, Neil Encabo, Carl Joshua Garcia, and Kyle Duffy Saison, to introduce the plan and design of the Tanawin Airport. The proposed name for the first airport facility in Tanauan, Batangas is Tanawin. I will further explain the details of the airport design in the succeeding slide. First, the selected location for the airport is in Patlay, Matanda, Tanauan City, Batangas, with an approximately 4.79 square kilometer area and 8.71 kilometer perimeter as shown in the figure. The largest aircraft to be accommodated and considered in the capacity of the components included in the airside is the Boeing 777-300ER. Next, for the target beneficiaries, the proposed airport has envisioned to benefit the local community, the local businesses, the global market in terms of industrial and commercial trades and the service of aircraft beneficiaries. Next, in the planning phase of the airport design, we have considered the flows in the two major components of the airport, which are the airside and the landside. The airside design should consider the flow of aircraft, the runways, taxiways, aprons, and hangars. Meanwhile, the landside part shall comprise of the people flow consideration in the terminal building and the flow of land vehicles. Other design considerations include the long-range goals and development, multimodal transportation system, environmental aspect of the design, and the required facilities for the airport.
The level of forecasting applicable is the disaggregate forecasting, where we are concerned with the activities at specific airports or routes. How many is the number of origination, the traffic density, and plane passengers and freight operations. We also need to specify the design years. Is it just for a short-term forecast, medium-term, or long-term forecast? And the least expensive and most attainable forecasting method is the market share method, where we just proportion large-scale aviation activity down to a local level. CAAP website has accessible data online, and it gave us this function of airport percentage of annual employments for Calabarzon region that spans for about 7 years. Our implicit assumption is that the relationship between this data of regional annual employments and annual employments at the Tanawin Airport will be maintained in the future. As you can see in the graph, the trend line forms a linear expansion. The points are then located using our design years, and we projected future employments for about 9.2% by 2022 and 9.8% by 2027. Once we projected the function through percentage, we will need existing quantity of employment to perform the proportioning. From CAAP, 2019 has 49.88 million, to 2018 has 48.67, and 2017 have 42 million of employments. And the final step on market share method uses extrapolation. Using the trend line in the previous section shown, it indicates regional annual employments at year 2022 of 51.98 million and by year 2027 of 55.32 million. So this is not the final results, no? The actual forecast is multiplied by the percentage of growth, about 4.8 million passengers by year 2022 and 5.4 million by 2027. That will be all for forecasting for airport planning. We now proceed to discussing the project design for Tanawin Airport.
Now let's proceed on the project design. The layout of the airside. The layout of the airside as seen in the figure includes the geometric design of runways, taxiways, and all the included facilities. As you can see, all the facilities mentioned earlier were clearly identified in this figure. The orientation of the airport is north 10 degrees east. The layout of terminal should consider the fluidity of the passenger flow throughout the airport terminal. The space programming for the arrival floor and the departure floor will be discussed. To start, as you can see in the figure for the layout of the arrival floor, there are 9 number symbols under which corresponds to different parts of the arrival floor. The first one is security. The second one is the baggage arrival. The third one is the arrival curb. Fourth is the cargo arrival area where larger baggages go and wait for pickup. Fifth is the arrival lobby. Sixth is the waiting area or the taxi lobby where people wait. Seventh is the comfort room. And lastly is the ATM or the automated teller machine. Now let's proceed on the departure floor where passengers are boarding on or are waiting to load the aircraft. As you can see in the figure, there is the outbound baggage where baggage are waiting to be loaded. Security, passenger departure 1 to 6 where passengers actually board the aircraft. Cargo departure gate, departure lobby, curb front, air offices and ticketing where people get their visa approved and avail tickets for international and domestic flights, and comfort room. Next slide, please. Let's proceed on the road network of the proposed Tanawin Airport, which is divided into 2 road networks, the inside and the outside road networks. For the inside road network, upon entering the airport, there are 2 different roads which branch to the parking space provided and the pickup areas. The parking has an entrance separated from its exit to provide a smooth flow of vehicles. As you can see in the figure, there are designated pickup areas. Yellow depicts the area for the passengers who arrive from domestic flights, whereas blue represents the pickup area for the passengers who arrive from international flights. And lastly, the drop-off areas is in green color. For the external road network, the access roads link to the road leading to the Southern Tagalog Arterial Road Star Tollway and are designated as 2-way roads. However, on General Luna Road, it will be designated as a one-way road to have an efficient flow of traffic considering the number of intended users of the airport.
For the hazard report, there are 2 hazards that may greatly influence the construction and operation of the airport. Those are the wind velocity and the seismic. The wind parameter in the location has been assessed through the hydrometeorological hazard, which indicated that Tanauan City, Batangas is subjected to severe wind hazards from 117.1 to 220 km per hour wind velocity for a 20-year return period and a 500-year return period. On the other hand, the West Valley Fault line is the nearest active fault, which can be traced along Tanauan City, Batangas at 6.9 kilometers northwest of the proposed location of the Tanawin Airport, which is shown in Figure 12. Next, based on the map, the site lies at intensity 8 or higher on the PVOX Earthquake Intensity Scale or PEIS, with very destructive to devastating ground shaking. This is justified by the distance of the site from its nearest active fault, considering intensities during various earthquake scenarios. For countermeasures of the wind velocity and the seismic, for wind velocity we have site location, wind resistance design, wind monitoring and forecasting, emergency response plan, and training and awareness. And on the other hand, we have for the seismic, first is the seismic design, ground improvement, emergency response plan, equipment and infrastructure protection, and monitoring and maintenance.
Now, here provided are the list of facilities, considering their designs, discussing also their capacities as presented for the following slides. For the runway, it is considered for the specifications of lift-off distance, distance to height of 35 feet, stop distance, from the different considerations of takeoff or normal takeoff, engine failure takeoff, normal landing, and obtaining the maximum for the field length and full strength pavement, we get the following considerations of for the field length, the 9,315 feet or roughly 2,900 meters, the full strength pavement length of 8,107.5 feet or roughly 2,500 meter length. Now for the taxiway, herein provided are the general considerations of Tanawin Airport taxiways, as well as the considered taxiway geometry. For the hangar, we intended to have the projected area of 5,750 square meters consisting of 6 hangars. For the apron, we intend to have a projected area of 12,350 square meters consisting of 5 aprons while considering the clearance capacity versus the actual capacity of 7.5 with less than 270 meters. Next, for the aircraft stand, we intend to have projected area of 530 square meter, having an approximate of 3 to 4 aircraft parking lots. For the control tower, it should be seen that there is a clear line of sight from the air traffic control tower to all taxi lane center lines as per Federal Aviation Administration's control tower visibility requirements. Tower locations must provide clear, unimpeded lines of sight to the landing area, all runway and taxiway surfaces, and maximum visibility to traffic patterns. Next, for the front projected area, we intend to place it near to the apron with a projected area of 37.46 square meters. For the maintenance building, it is desired to have a projected area of 1,500 square meters upon the consideration of site constraints and its proximity to the apron, as stated earlier. Now for the open parking area, to provide continuity as well as to reduce carbon footprints, employing one-way distribution of traffic, reducing the flow, we have considered a projected area of 53,000.07 hectares. Now for the terminal building, considering the departure and arrival on a two-story basis, we intend to have 72.37 hectares of that. For the fire station, consisting of 2 designated fire stations, we intend to have 2,500 square meters of projected area. For the fuel depot, the allotted area for the vertical tanks consisting of 2,000 liter storing capacity is 14,300 square meters. Moreover, the general aviation should consider the use of public airports with no scheduled services or less than 1,500 boardings per year. The NPIAS includes around 88% of general aviation airports, which will be also employed in the design of facilities of general aviation. Lastly, for the waste management facility, every airport must manage garbage, and putting in place efficient and cost-effective waste management techniques involves several obstacles. Successful airport waste management implementation has the potential to benefit airport authorities, customers, and the larger community by reducing and eliminating waste footprints outside, for example.
So for the methodology, we use the survey questionnaire. So for the data gathered, upon obtaining the responses from a total of 19 respondents, ages ranging from 21 to 65 years old from Tanauan City, below is the data gathered from the survey questionnaire. So we have 4 questions. Do you travel often? Do you travel by air? And do you travel by air locally and internationally? So almost half of the respondents do not travel by air locally and internationally. However, this will not be a hindrance to the proposed airport because of the following questions. First is the advantages of building the proposed airport. So almost all of the respondents agreed with the statements that there is an advantage of building the proposed airport in their community. Next, we have the disadvantages of building the proposed airport. So some of the respondents agree with the following statements. However, these disadvantages may be resolved through countermeasures in order to alleviate the possible risks to the community. So that is all for our group. And again, we are the Group 6 proposing the Tanawin Airport.